Greetings, math fans. All right, so this day we're going to add and subtract rational expressions. But if you remember from the last lesson, we added and subtracted where you had like denominators. So for example, if I had, this is from past days, if I had, 3/8, plus 2/8, that was easy, right? Because you had the same denominator, and so you just keep it the same, and then you add 3 plus 2, and the answer is 5/8. Pretty easy. Okay, so now what we're going to have is a problem where I have like 1/4 plus 1/3. And you might remember that from like back in the day when you first learned how to add and subtract fractions. You need a common denominator. Okay, so this is really important. So you need a common denominator. All right, and we don't have one right now. So what we need to do is we need to find our LCD, which is the lowest or least common denominator. Okay, least or lowest common denominator. So in other words, you're looking for a number that 4 goes into and 3 goes into, the smallest number that both of them go into. Okay, so in this case here, the smallest number that both 4 and 3 go into is 12. And it's kind of nice because actually 4 times 3 is 12. That's your worst case scenario is 4 times 3. We're going to do a few examples here where it's something even smaller than multiplying together. But in this case here, our LCD is 12. So I want to say, well, what times 4 gives me 12? Well, do you guys agree 3 times 4 gives me 12? So I'm going to multiply the top and the bottom by 3 over 3. And what I'm doing here, math fans, is I'm multiplying 3 over 3 is really multiplying it by 1. So the goal is I haven't changed the problem at all. I'm literally multiplying it by 1, but I'm getting a different denominator, okay? And so same thing with this thing. What do I multiply this 3 by to give me 12? Well, 4. So 4 over 4. So again, I haven't changed the problem at all. I have literally got a common denominator. So if you look at this now, if I multiply this guy together, I get 3/12. And I multiply this guy together, I get plus 4/12. Now, just as I did this guy right here, I can now add them together, right? 3/12 plus 4/12 is 7/12. And that's my answer. Okay, so you're always looking for the lowest common denominator in order to add them together so we get a common denominator. Okay, really, really important. So let's do a couple more examples just with numbers because I think it's important just to understand that with numbers. If I do, let's do 3/10 plus 2/15. It's a good problem. Okay, so the worst case scenario is I have to multiply it by 10 times 15. My worst case scenario is my LCD is 150. But that's kind of crazy. That's like a huge number. Kind of think a little bit, math fans. What does 10 and 15 both go into? I don't know. Now be careful. Don't say what goes into 10 and 15 because a lot of times kids will say, oh, the answer is 5 because 5 goes into 10 and 5 goes into 15. I don't care what goes into it. I want to know the largest number that it will go into another number. So I'm just going to write this out. Largest number that 10 and 15 will go into. Okay? And let's just kind of start out. If I multiply 10 times 2, it's 20. Well, does 15 go into 20? No. How about 10 times 3? Well, that's 30. Okay, does 15 go into 30? Yeah, it does. Okay, so my LCD for this problem is actually 30 because 10 goes into 30 and 15 goes into 30. So I'm going to multiply this one by, in order to get that to be 30, I multiply it by 3 over 3. In order to get this one to be 30, I need to multiply this by 2 over 2. Okay, so now you'll have 9 over 30 plus 4 over 30, which equals 13 over 30. All right, so that was a little more extreme. 10 and 15 are kind of bigger numbers. Let's try a different one. Let's actually just do it right over here without clearing the screen. We'll What if I said, let's say, we'll do a pretty straightforward one. How about 1/6 plus 1/4? That's a pretty good one. Okay, so you can say LCD is 24. And I'm going to show you actually why it'll work for both. But what is the biggest number, or the smallest number, I should say, that 6 goes into and 4 goes into? Well, you should think 6 times 2 is 12. Oh, wait, 4 goes into 12. So for this problem, guys, my LCD is 12. So I multiply this one by, what times 6 is 12? 2 over 2. Multiply this one by 3 over 3. Okay, so you get 2 over 12 plus 3 over 12. So the answer is 5 over 12. Now let's just say, for example, you didn't know that the LCD was 20. Let's say you multiplied together and you said, oh wait, the LCD is 24. That's okay. You're just going to have to reduce it at the end. So let's actually do it right over here. If I would have said the LCD was 24, let me write the problem out again. 1/6 plus 1/4. You would multiply this one by 4 over 4, because that gives you 24, and this one by 6 over 6, because that gives you 24. So you would get, oops, that's a 1 here, sorry. You'd get you get basically 4 over 24 plus 6 over 24, which gives you 10 over 24. And if you reduce that, you can use your calculator, I don't care how you do it, but if you reduce 10 over 24, you get 5/12. What? Same as that. Okay, so if you don't pick the best LCD with the number part, it's not a big deal. You just have to, it actually is more work at the end because you got to reduce it then at the end. Okay, so that's kind of how LCD works here a little bit. Let's just do one more because I think it's good practice, and I like practice. Let's do 1/6 plus 1/10. So I could do 60, but think, guys, what does 6 go into and what does 10 go into evenly? And you should say the LCD is 30. 6 goes into 30, 10 goes into 30. So I'm going to multiply this by 5 over 5 and this by 3 over 3. So I get 5 over 30 plus 3 over 30, which gives me 8 over 30, which I can reduce, which you always want to, okay? You want to reduce, and that's going to give you 4 over 15. Okay? Once again, if I chose incorrectly and I said the LCD was 60, you would, here, let me do the problem again, but I'm going to show you it's not a big deal, not a total loss here, math fans. You're going to multiply this by 10 over 10 and this by 6 over 6. So that would give you 10 over 60 plus 6 over 60, which is 16 over 60. And if you would reduce that on your calculator, you would get 4 over 15. You get the exact same answer. Okay? But this is, it's you know, if you can avoid that and get the right one right away, that's kind of nice. Okay, let's throw some variables in here now, because it's not that much more challenging, but let's just do that, okay? So this is with variables. So if I have 3 over x to the, or 5x to the fifth, 3 over 5x squared, sorry, plus 2 over 7x. My LCD is easy for the number. What does 5 and 7 both go into? Well, there's no smaller number, so that actually is 35. And then what you do is you choose the highest exponent. And if there's more than one variable, you choose the highest exponent for each variable. So the highest exponent is x squared, and that is your LCD. Okay? So you want to say, well, what is this? This is easy, right? 7 and 7. We know that because to get 35. And you guys agree, I already have x squared, so I don't need to multiply that by anything. And what does this one have to be multiplied by? Well, 5 and 5, and it needs to be an x squared, so you multiply it by x over x. Okay, so look at it. I mean, you can even see that in your denominator, here's 35x squared, and here's 35x squared. And then you're good to go. Okay, so let's write it out now. It's 21 over 35x squared plus 10x over 35x squared. So your answer is, and I like to put it here, let's just write it this way, 21 plus 10x over 35x squared. And I like to write the top, guys, in descending order, right? Standard form. So 10x plus 21 over 35x squared. That's it. That's your answer. Now you always look to see if you can factor this. In this case, we can't. Sometimes you can, but always look to see if you can factor it. Okay? All right, let's try another one. These aren't really that bad. 3 over 10x minus 3 over 4x squared. All right, we need an LCD. Well, what does 4 and 10 go into? You could do 40, but think, what does 10 go into and what does 4 go into evenly? 20 is your LCD. Okay, what's the biggest exponent? X squared. Okay, so what do you multiply this one by? Because we got to get, now we have to get that denominator to 20x squared, so we're going to multiply it by 2x over 2x. Okay, cool. And what about this one? Well, it's already got an x squared, so it's just 5 over 5. All right, that's cool. So there we go. We know our denominator is going to be 20x squared. So do that. Write 20x squared and put a line underneath or over it, and then just multiply the rest of it. 3 times 2x is 6x minus 15. Okay? And remember I said, if you can, factor the top. So I can take out a 3. You guys should see that. So if I factor out a 3 and divide each of those by 3, I get 2x minus 5. And then that's over 20x squared. Now, if I could cancel something, I would, but I can't. So this is my final answer right here. You know, and if I could cancel, you guys know about canceling. If I could cancel those two, that would be what I would cancel. But we're done with the problem. Okay? All right, let's keep going here. Problems get a little trickier, not too much. So 2 over x minus 3 over x plus 4. All right, so here's the deal. This is, again, it's a little tricky, but guys, our LCD, there's nothing in common between that x and the x plus 4. Our LCD is literally x times x plus 4. That's the LCD. Okay, so just to do a couple more, I'll do this one in a second here, but I don't care what, if I, let me just use a 1 here. So if I have 1 over x plus 2 plus 1 over x minus 2, the LCD, there's nothing in common between these two. So I'm going to say the LCD is x plus 2, x minus 2. Okay, so let me do another one. If I said 1 over 3x plus 1 plus 1 over 3x plus 5, my LCD is both of them again. It's 3x plus 1, 3x plus 5. So that's, it's just understand, you need to understand that usually, all right, so anyway, there's nothing in common between these two. So 3x plus 1, 3x plus 5, that's my LCD. Really easy, it's pretty easy to do these because there's usually nothing in common. Okay, so if I did, let me kind of delete everything here. It doesn't matter what it is. You know, x plus 5 and, you know, 1 over that plus 1 over x minus 6. The LCD is x plus 5, x minus 6. Okay? It's just kind of easy to do that. So let's go back to our original problem. So we have 2 over x minus 3 over x plus 4. So again, my LCD is x times x plus 4. So I'm going to multiply this first one by x plus 4 because it needs an x plus 4. And this one by x over x. Okay, it's pretty easy. So now look, math fans, this has got an x times x plus 4, and this has an x times x plus 4. So that's what goes in the bottom, x times x plus 4. And now we draw one line like this, and the only issue, or not, I shouldn't say it's an issue, you just have to multiply this out now. You have to multiply this, and watch out for this negative. Okay, so if I distribute the 2 with both those terms, I get 2 times, let me write it out here, 2x plus 4 minus 3x. So I really get 2x plus 8 minus 3x over x times x plus 4. Okay, so that means 2x minus 3x is negative x plus 8 over x times x plus 4. Nothing I can factor, so we're done with the problem. Okay? So always look to see if you can factor this. It doesn't always happen, but always look to see if you can factor it. Okay? All right, I got a couple more to do here with you guys. Okay, so 3 over x plus 3 plus 6 over x plus 6. Well, what's your LCD? Again, it's super easy. Just look at it. It's x plus 3 times x plus 6. Okay, so what does this one need? It needs an x plus 6. And what does this one need? X plus 3. Okay, so again, I'm going to write it out as x plus 6, x plus 3. So now write it on the top. You know, it makes it easy when you just write this as 3 times x plus 6, and then plus 6 times x plus 3. Write it out like that. And then distribute the top. So you get 3x plus 18 plus 6x plus 18 over x plus 6, x plus 3. So add the top, so we get 9x plus, that's 36, over x plus 6, x plus 3. Okay, and then I can factor something on the top. I can factor a 9 out. You should recognize that. So I'm going to take a 9 out of there. I get 9, and then that gives me x plus 4. And underneath is x plus 6 and x plus 3. And there's nothing I can nothing to cancel, so that's my answer. Okay? Sometimes you can cancel, and then you got to be careful. If you can cancel, then you do that, and you know, and then it makes it then it simplifies the whole fraction. Okay? Okay, so I can do one more with you guys, and that's it. Okay, so for the last problem, it looks a little scary, but it's 4 over x plus 5 times x plus 1 minus 3 over x plus 4 x plus 1. So if you look, they both have x plus 1, but this one on the left has an x plus 5, and the one on the right has an x plus 4. So actually the LCD for this one, LCD is everything. So it's got to have an x plus 5, it's got to have an x plus 1, and it's got to have an x plus 4. That covers everything in both of those fractions. Okay, so again, it's not a big deal, but it just means you're going to multiply this guy over here, and it's missing an x plus 4. So multiply this by x plus 4 over x plus 4. And this one is missing an x plus 5. So multiply this one by x plus 5 over x plus 5. Okay? No big deal. So I'm going to draw one big fraction. So I can put x plus 4, x plus 5, and an x plus 1. And then I'm going to write this, it's 4 times that, so I'm going to show my work, 4 times x plus 4, and then minus 3 times x plus 5. Now the deal is, don't forget guys, it's a negative 3, right? It's the negative 3 that needs to be distributed to both of those. That's why I kind of showed you, I kind of wrote it this way, right? So then you can distribute that. Okay, so let's do it here, right? So we're going to get 4 times x is 4x, 4 times 4 is 16. Negative 3 times x is negative 3x, and negative 3 times 5 is negative 15 over x plus 4, x plus 5, x plus 1. So now we combine like terms. That gives us x plus 1 over x plus 4, x plus 5, x plus 1. Ah, look at that. Now we have an x plus 1 that can cancel. And guys, remember, when you cancel, there's still a 1 on top there. Okay, don't put 0. It doesn't make sense. Okay, it's 1 over x plus 4 and x plus 5. And that's your final answer. Okay? So these are not difficult. You just have to get, sometimes with the numbers, you have to make sure, try to do the best you can to find the best LCD. When you have variables, especially in x plus 1 and x plus 5 and x plus 3, whatever, it's actually really easy to find the LCD. It's really just a combination of all of them to give you a common denominator. Okay? So do your homework and practice the problems because it does take practice, and then you guys will be good to go with it. But again, finding the LCD, you combine the fractions together, and then always look to see if you can factor the numerator, and then see if you can cancel, just like we did in this last problem, where you can actually do some canceling. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.